Hi, I'm Vasudev Chittarelli and today I'm going to give you a short presentation on stress and strain. So what is stress and what is strain? Before talking about stress and strain, I would like to introduce three main properties of any material, which are elasticity, plasticity and a breaking point. So what is elasticity? Elasticity is the tendency of solid material to regain its shape and size. So when a force is applied on an object, the force, which is called a deforming force, changes its shape and size, and when the deforming force is removed, the body tends to get back its original shape and size, which is called restoring force. So the next one is the plasticity, where a body cannot change its shape and size after a deforming force is applied on the object. And the third one is the breaking point, where the object is subject to more force after the plastic stage and the object goes into a breaking point or rupture point. So the force applied on object is called the stress, and the change in length or size is called the strain. Mainly there are five commonly considered forces when designing any structure, and they are tension, compression, torsional, shear and bending forces. So what is the tension? Tension is defined as a pull, and it is the stress of stretching the body at the ends. Compression, it is the opposite of tension, which is push. Torsional is the stress results from a twisting force. For instance, torsion is produced in an engine crankshaft. The next one is the shear, which is exerted when two pieces of fastened material are pulled or tend to separate. Bending is the combination of tension and compression. For instance, when you bend a tube, on the outer side of the tube, you got the tension, and on the inner side or underside of the tube you got the compression. Now coming to the strain. Strain is defined as the ratio of change in length to its original length, and strain has no units because it is derived from two like quantities. There are mainly three types of strains, which are linear strain, volume or bulk strain, and shear strain, which is equal to the angle of shear. So looking at the graph of stress versus strain of rubber, you can see that rubber has undergone through different stages, the elastic, plastic, and finally to the fracture point. So you might be thinking, what is the need of learning stress and strain? So from the graph we can find the yield strength of any material, and the Young's modulus of elasticity, which is represented by E, where it is the ratio of stress to the strain, and its units are psi. Based on this Young's modulus of elasticity E, the property of material can be clearly understood, and appropriate materials for vertical applications can be used. Especially from design and engineering perspective, E value is useful in the selection of appropriate material. And you can see this table where the value of rubber when compared to the value of concrete, the value of E of rubber is less than the concrete, which signifies that the rubber material is flexible, and when compared to the concrete material, which got a lot of stiffness. So it is the responsibility of every engineer to go through the material properties before they are going to be used in their specific design or construction. Thank you.